Yes, yeah. Shall I start the class or
Yeah,
we'll
yeah.
wait for some more time?
No, no, you can start the class, not a problem.
Okay, fine.
Yeah.
So in the last class, we have discussed with like star schema and snowflake schema, and we do have galaxy schema. So we do have galaxy or hybrid schema. So it's simple, like star schema is nothing but like whatever the fact table we have, right? Fact table is surrounded to like multiple dimension tables, and which we have a direct joins between fact table and dimension table. And snowflake schema is nothing but it's a normalized schema, and that dimension table is divided into multiple dimension tables, and which the dimension tables are indirectly related to the fact table. That is called as a snowflake schema, and we have already seen with a difference in SQL. And we do have galaxy or hybrid schema. It's a simple definition. So in general, galaxy is nothing but collection of stars. But here, galaxy is nothing but collection of like it's a combination of star schema and snowflake schema. Galaxy or hybrid schema, it's a combination of star schema and snowflake schema. And I just want to showcase the schema here. So how to build a data model. So for at least like 10 minutes. So then we can move on to the next topic. Already we have seen, right? So I'll just go back. So we have an access database. So let's take the same example. We have day center sales and city center sales or whatever the fact tables here we have. So let's drop day center sales. In general, to build a schema, first we need to identify those or requirements gathering. First point, requirements gathering. So pull those required tables into Tableau. I want to go with day center sales and check with the data here. So day date, call center ID, and we have facts. So now drop LU underscore day, because already we have discussed this. So LU underscore day, and then next you can go with the month table. Next you can go with the quarter table, LU underscore quarter. And default, it is not the perfect alignment or something like a parent level or a parent and child relationship. Let's go with the LU underscore quarter. I want to relate quarter table to month table. Drop down. So let's go with the month table. In that month table, we have quarter ID. Make use of quarter ID here. And let's drop LU underscore year table. Now go with LU underscore year, drop down, and make use of quarter table here, LU underscore quarter. From this particular table, you can relate with year ID. So this is what the snowflake schema with time dimension, LU underscore day, month, quarter, and year. But if you want to go with one more like dimension or one more hierarchy, something we have already discussed, right? Let's take, we have call center, but I want to go with sales related information. Once again, if you have item month sales, drop here. This is important. Just concentrate on this. So while working with item month sales, first point we already discussed, don't go with fact table to fact table relationship. So that is what I have said, right? So don't go with fact to fact relationship. And if you can see here, day center sales is a fact table and item month sales is also a fact table. Let's check with the data. So gross dollar sales, item ID, month ID, and we have all this like let's stop here. So we do have two key columns. It's a fact table, right? We do have facts and key columns. 1 second. So I'm getting an issue here with GoToMeeting. Okay, let's see. So we have this particular fact table, right? So let's close. So now you can see, don't relate fact to fact relationship. First point, don't go with fact to fact relationship, fact table to fact table. And we have a relationship here. So by default, we are getting gross dollar sales as a key column. So fact is acting as a key column. So it is not the perfect relationship. So because don't go with the facts as a relationship, as a key column. So go with only ID columns, or you can use description, but don't go with facts as key columns. So try to avoid this particular gross dollar sales and make use of month ID, because we have month table here. Make use of month ID. Now click on this particular join gross dollar sales from item month sales, make use of month ID. Now click on the drop down, because now you can see there is no data. So drop down, make use of month table and month ID. So by making use of month table, I'm going to relate with fact table called item month sales. So my level of granularity is item month sales. So this is one more granularity or one more hierarchy. Got it right? It's a kind of a snowflake schema where we have a parent and child relationship. Let's check with item table. So we have item long description, and we do have different languages, Korean or Chinese or different internationalization languages. Now you can see we have subcategory ID, or we do have brand, correct? If you want to relate with brand table, you can drag and drop brand table. If you want to go with a subcategory, go with subcategory ID. Let's drop subcategory. Now you can see item subcategory, and let's check with subcategory here. Any key column. So we have category. So this is a parent. Category is a parent. So still loading. Now you can make use of LU underscore category. You got it right? So this is a snowflake schema. So we have item, subcategory and category, and we do have like day, month, quarter and year. So this is what the level of granularity we have. This is what the level of granularity. So by making use of snowflake schema, you can build the data model, and you can make use of those reports and dashboards. You can build those reports and dashboards. So this is very important. So data modeling. So you need to identify the key columns, and you can establish your relationship by making use of that particular key column. Any questions here? Building a data model. In general, we need to identify the columns first. Requirements gathering, pull those required tables into Tableau and establish a relationship between those tables. You got it right? So this is for the data model, and you can pull those related information. And if you want to go with day center sales or day level or city center sales, you can build those relationships. So I do have city center ID. In day center sales, you have one more key column here, call center ID. You can drop call center ID table, dimension table. Then you can build one more hierarchy related to call center ID. So that we can drop all the tables and we can build a data model. It depends. It depends on the business and depends on the project where we need to pull those required tables, and we have to build those data model here. So this I'm going to share it to you. And whatever the worksheet, right? Tableau worksheet, and also with the access database, like we do have access database tutorial data. I'm going to share it with you, so no issues with that. This is what Galaxy. Like Galaxy is something like combination of star and snowflake schema. combination of star schema and snowflake schema. But important question is like, what is the difference between star and snowflake schema? That is very important. Difference between star schema and snowflake schema. So now we'll discuss with types of facts and types of dimensions. Then we can start with Tableau. So it's simple definition, types of facts. It is not that much important, but we'll go with the definitions and some more points here. So we have types of facts. So what are the different types of facts we have? So we have additive fact, semi-additive fact, and non-additive fact. So additive fact, semi-additive fact, and non-additive fact. So when it comes to like types of facts, let's take a fact table. Let's take a fact table here. So when it comes to like additive fact is nothing but aggregatable. So aggregation, sum, average, minimum or maximum, right? We should get a meaningful data. So what is meant by additive fact? So if a particular fact is going to aggregate, if a fact is going to aggregate across all the key columns. So in a fact table, so the definition is if a particular fact is going to aggregate across all the key columns within a fact table is called additive fact. So I will go with the definition here. So if a particular fact is going to aggregate across all the key columns within a fact table is called additive fact. So now you can see, let's take sales. So I can go with day-wise sales, I can go with city-wise sales, customer-wise sales, and item-wise sales. Got it right? You can create any particular report. So by making use of day-wise sales, I can go with individual day-wise sales. I can go with the individual city-wise sales. So customer-wise sales information and item-wise sales information. So this is what like aggregatable or additive fact, but the definition is important. Like it has to aggregate all the key columns. If we have 100 number of key columns within a fact table, it has to aggregate all the key columns within a fact table. Got it? So that is called additive fact. So if a particular fact is going to aggregate across all the key columns within a fact table is called additive fact. Example, you can go with sales or revenue. So this is the same definition, right? All this. So, but what is meant by semi-additive fact? If a fact is going to aggregate across only few key columns, let's take I have balance, account balance or salary, account balance, or you can go with the salary. So I do have two facts here. So balance and salary. So now you can see account balance wise day. So I can go with day level balance. Let's check with day level balance. So whether it is an aggregatable or non-aggregate. So when it comes to like day wise balance, this is individual balance. So for the user's perspective, when it comes to like user perspective, it is not going to like helpful for the day wise balance. So it is not like one single user or one single customer wise balance. So this is total. We do get a grand total. So day wise balance is also a non-aggregatable because across customer level, we need a customer wise account balance. So city wise, I don't want city wise balance. Item wise, we don't have item related to like items with account numbers or account balance, right? So the balance is going to aggregate across customer wise, customer account wise balance, or customer ID or customer wise balance. Got it right? So you can go with customer ID or make use of employee. If you have a salary, you have to go with employee by salary. item wise salary is not possible. So this particular fact, that is what, like if a fact is going to aggregate across only few key columns, that is called semi-additive fact. Additive fact in the sense, if a fact is going to aggregate across all the key columns, and semi-additive fact, if a fact is going to aggregate only few key columns, is called semi-additive fact. And what is meant by non-additive? It's a non-aggregatable fact. So let's just remember, for non-additive facts, it's a simple definition. We are not going to work with all these things. So it's to identify whether it's an additive fact or non-additive fact, but it's not that much important. Got the point, right? So non-additive fact is nothing but it's something like calculations or ratios. If you are going to perform any ratios or percentage calculations or something like gross profit margin or net sales margin. So whatever the percentage calculation we are going to do, right? It's like something like revenue by sales or sales by revenue, or that is what, like those calculations are called non-aggregatable or non-additive fact. So these are types of facts. It's a simple definitions. And we do have one more concept called factless fact table. So additive fact is nothing but if a fact is going to aggregate across all the key columns within a fact table is called additive fact. So aggregation. So that is what aggregation. So let's take sales. Any particular fact, you can take any fact, that particular fact is going to aggregate. We should get a meaningful data. Day level, I have to get a like aggregation. City wise, I have to get an aggregation. Customer wise, I have to get an aggregation, and item wise, I should get an aggregation. So that is what, if a particular fact has to aggregate across all the key columns, is called as an additive fact. Got it, right? So you can see salary. Salary is not going to aggregate across item level or city level. So city wise salary, it is not possible. You got it, right? So whatever the aggregation, right? So you can perform aggregation, but you should get a meaningful data. So we do think that within a fact table, we do have all the key columns, but whatever the key columns we have, right? So it's not like, it's not mandatory to get an aggregation here. We do have some more facts which related to this particular key columns. So that is what the concept. Additive fact, semi-additive fact, and non-additive fact. Clear? Yeah. So factless fact table. So this is important. Like sometimes, like they do ask, like how to avoid cross joins. So what is meant by cross join? Cross join, or if we don't have an example for additive fact is sales. So whatever the sales, right? So you can take any example. Sales is going to aggregate across day-wise sales. You can see day-wise sales, individual city-wise sales, customer-wise sales, individual customer-wise sales, and you can go with individual item-wise sales. So that is possible. You can go with the sales as an additive fact. And we have factless fact table. So what is meant by factless fact table? So factless fact table is nothing but like if we have a fact table, but we do have only key columns. If a fact table contains only key columns, that means only ID columns, and if we don't have any facts, is called factless fact table, or we can also call it as bridge table. We can also call it as bridge table. So what is the use of factless fact table or bridge table? It's something like a connectivity between those tables. If we don't have a relationship between two tables, we can relate by a simple key columns. Let's take a have these key columns. Got it? So if we make use of these particular key columns, or we can also call it as linking table, link table. So I have a day dimension table, and I have a day ID, and I do have customer related table, but I don't have a direct relationship between day table and customer table. So now make use of this particular table. So we do have fact table, because by making use of, to get the information of sales related information, we have to place day ID, customer ID, city ID. But if you want to relate with any particular table, got it right? So something like day table or city table or item table, you can make use of only ID columns. Got it? You can make use of ID columns, day ID, city ID, customer ID, and you can go with any particular table. So by making use of factless fact table, so that is what? To avoid cross joins or to avoid in some of the cases, right, you can make use of many to many. So to avoid many to many relationship, we can also go with factless fact table. So convert many to like convert to many to one. If you have many to many relationship, convert to many to one and then one to many. 95% of the case, right, we need to avoid many to many relationship. In some of the case, I have seen like in some of the manufacturing domain, I have seen like many to many relationship is mandatory there. Correct. So in some of the cases, we can go with M to M relationship, but most of the cases to avoid cross joins or many to many relationship, you have to split or you have to go with a factless fact table or bridge table or aggregate tables. You can also go with some aggregate tables for a better performance. So that is what like yesterday we have seen, right? So every time if you want to go with year-wise sales, it has to aggregate across all this level. I want to aggregate across day level, month, quarter, and have to go with the year-wise. So every time if you're going for year-wise sales, straight away you can build an aggregatable table. Aggregatable table in the sense year-wise sales. Straight away I have to go with year and sales in one single report or one single table. So database team is going to create this aggregatable table so that most of the like reporting tools, right, it prefers first. So it prefers to hit the aggregatable tables. So we can make use of aggregatable tables to give a better performance. So that is what the importance of aggregation. So if you are using star schema, you will get a perfect like it gives a better performance. But when it comes to like snowflake schema, every time if you want to aggregate across multiple levels, it degrades the performance. So or if you want to go with factless fact table or if you want to establish the relationship between those tables, so build a bridge table or factless fact table. And we can make use of those tables for establishing relationship. Got it? So factless fact table or bridge table, or we can also call it as linking table. So to link multiple tables. So cross join is like we cannot go for cross join. It's something like we do get multiple combinations. This is important. Like try to avoid cross joins. Try to avoid cross joins and establish a perfect relationship. So whatever the data modeling, right? So this is very important because first, we can create those visualize the dashboards and reports in Tableau, but when it comes to like data, if we have a mismatch of data, so it is not useful. So we have to go with the perfect data model. No, it's a naming convention. There is no difference. Like factless fact table or a bridge table is same. Factless fact table contains key columns and bridge table also contains key columns. It's a naming convention. You can use any particular naming convention. Factless fact table or bridge table, or you can also use link table. But most of the case we do call as factless fact table or bridge table. So we do have types of dimensions. So when it comes to like types of dimensions, one important point here, like we do have a very important question here, slowly changing dimension. These definitions are simple. And when it comes to like interview perspective, yes, factless fact table and whatever the, yeah, factless fact table and bridge table are same. So that is what I say, right? You can call factless fact table or bridge table, or you can also call as link table, something like linking. So if you want to go with a join, right, or if you want to establish a relationship, it's something like a link by making use of this table. So we have types of dimensions. So we have conformed dimension. shrink, role play dimension, degenerate dimension, junk dimension, and importantly, we do have slowly changing dimension. Importantly, we do have slowly changing dimension. So we have conformed, shrink, role play dimension, and we do have degenerate dimension, and we can also go with the junk dimension. But this is very important, slowly changing dimension. Important interview question. So what is meant by SAD? We can also call it as SADs, types of SADs. Slowly changing dimension type 1, type 2, and type 3 on a high level. So types of dimensions. So what are the different types of dimensions we have? Conform, shrink, role play, degenerate, junk dimension. So what is meant by conformer dimension? What is meant by conformation? You got it right? Conformation meaning. So if a particular dimension, if a dimension is going to relate, if a dimension or dimension table is related to more than one fact table, so we'll start with Tableau after this particular types of dimensions. So it's a simple definition, but we need to go with this definition because like in most of the interviews, right, they do ask like the simple definitions of data warehouse. They'll check with the basics. So conformer dimension, if a dimension is related to more than one fact table is called conformer dimension. So we may have conformer dimensions. Like let's take this particular example. So we don't have a confirm, but if it is month is straight away related to this particular whatever the fact table, right? If month table is related to day center sales, and if month table is related to item month sales, then this particular dimension is called confirm. But if we don't have a month directly related to the fact table, so that is what the definition. If a particular dimension table is related to more than one fact table is called conformer dimension. But in general, we are not going to call this dimension as conformer dimension. It's a normal dimension table. It's a normal relationship. So like star schema, if a particular fact table is surrounded by multiple dimension tables and which have a direct joins between fact table to the dimension table. But conformer dimension is almost opposite to star schema. So never go with the opposite to star schema in interviews or when it comes to like explanation point of view. But I'm just uh, like go with a comparison here. So conformer dimension is nothing but if a dimension or dimension table is related to more than one fact table, is called conformer dimension. And shrink dimension. So what is meant by shrink? It is almost similar to snowflake schema. Similar to snowflake schema. So shrink dimension is nothing but if a particular dimension table. So what is meant by snowflake schema first? If a dimension table is divided into multiple dimension table, that is normalization, and that dimension table is indirectly related to the fact table. So this is called snowflake schema. So what is meant by shrink dimension or shrink dimension table? So whatever the dimension tables we have, right? So whatever the dimension tables which are indirectly related to the fact table, the dimensions or dimension tables which are indirectly related to the which are indirectly related to the fact table is called strength dimension. Got it? So it's the same, right? So when it comes to like snowflake schema, so we have year table, we have quarter, month, day. So day table is directly conformed is different. Conform like it's a concept to go with a fact table. Conformed dimension is related to the fact table, right? So if a particular dimension is related to more than one fact table, it's called as a conformation, conformed dimension table. But in general, snowflake schema, or you can go with the strength dimension table. So strength dimension is every time. So whatever the dimension table, right, which is indirectly related to the fact table, it's called strength dimension. So here you can see, right, so here we have day table is not a conformed dimension because day table is not related to more than one fact table. Conformation in the sense we have to relate with multiple fact tables. Conformed dimension in the sense a day table has to relate with another fact table. That is first point. And strength dimension is nothing but if a dimension table is indirectly related to the fact table. How many fact tables we have? So we don't want to bother about the number of fact tables, but the particular dimension table is indirectly related to the fact table is called strength dimension table. It is similar to snowflake schema, but we don't have a concept called normalization. So we have year table is not direct, quarter table is also not direct, and month table is also not direct. So we have a day table is directly related to this fact table. So that is what the concept like strength dimension table is, which is indirectly related to the fact table. Any questions here? These are simple definitions like conform, it's a confirmation. I think you know, like you are aware of permanent jobs and contract jobs. So in general, we have permanent and contract, right? But when it comes to like permanent jobs, when it comes to like permanent, we have prohibition period. So at least like 3 months or 6 months, 3 months or 6 months, it's a prohibition period. And in contract jobs, we do get straight away salary. Like if it is like, let's take a 5 lakhs or 6 lakhs salary, right? So we do get straight away, like divided by 12, and we may have some deductions like 200 or something. It depends. But when it comes to like permanent, if it is a permanent job, right? In offshore, if it is 6 lakhs package, so we are going to get some more deductions. We may have some variable pay. So 6 lakhs divided by 12, we will get 50,000. But as a permanent employee, it deducts like we have PF and all those, whatever the deductions, right? Some variable pay 10%, and we do get almost close to 40,000 or 38,000. So we have a huge difference between contract jobs and permanent jobs. For contractors, we do get almost more than 48,000 plus, but as a permanent job holder, you do get 40,000 because we do have some deductions. But we may get those quarterly bonus and performance bonus, all those things. But this is what the point. But permanent job in the sense we have to go with the prohibition period for 3 months or 6 months. For MNCs, we do have 6 months, and for level 3 or level 2, like we do have 3 months of prohibition period. So in that particular period, he is a permanent employee. He's a permanent employee, but in that particular period, he is not yet confirmed. Got it, right? He is not yet confirmed. That is what confirmation. He's a permanent. So after the 3 months, so he is not a contract for this particular 3 months. He to get the same salary, but he is not yet confirmed. That is what confirmation. So in the same way, if a particular dimension is related to one fact table, it is not yet confirmed dimension table. If the same dimension is related to more than one fact table, if a particular dimension table is related to more than one fact table, is called confirmed dimension table. You got it, right? So this is what confirmation, and we have like, yeah, thanks. We have role play dimension. Role play, you know, like roles and responsibilities. We do have multiple roles and responsibilities. So as a developer, we need to involve in requirements gathering. the SDLC process, requirements gathering, preparing some technical design documents, establishing those estimations, sorry, not establishing, like preparing those estimations. And we can also go with some design and development phase, deployment, unit testing, right? More like we do have like different environments, migration into production environment or UAT or whatever the environments, and we can go for go live. So that is what the SDLC process, but in that we do have roles and responsibilities. And as a developer, we need to go with all these requirements gathering and preparation of those technical design documents. But when it comes to like role play dimension, or like team leader, TL acts as a lead, right? Acts as a lead, and he has to go with the development part as well. He has to work. So he has two roles, like he has to lead the team and he has to involve in the development part. So in the similar way, so we have a role play dimension. This is important. Sometimes we do face same kind of a things in reporting side, a role play dimension. So if a dimension plays multiple roles, if a dimension plays multiple roles is called role play dimension. And we need to avoid, that is what the important point, we have to avoid role play dimension. We have to avoid role play dimension. Why we need to avoid role play dimension? Let's take a simple example. So when it comes like user perspective, this is important. We are not going to develop these reports for ourselves. Whatever the reporting, right? So we have to publish those reports or dashboards for the users, and they are going to access these reports. And when it comes to like role play dimension, let's take an example. I have a date column. I know this is a date. I'm using the same date for start date. I'm using the same date, whatever the date, right? I'm using the same date as start date, and for some requirement, I'm going for end date. But in the reporting side, I'm going to showcase the same thing, date, some 12/3/2016, and let's go with the date. You got it, right? I do have two dates. So when we mention this particular date into reporting side, so the user may confuse this particular dates by making use of these dates. So what is this date and what is this kind of a date? So that means if we have a, like I know this is a start date, I know this is an end date, but the users are not aware of this particular date. What is start date and what is end date? So you have to make use of aliases. You have to make use of aliases, alias, so to avoid role play dimension. So, or you can also duplicate those tables and you can make use of replication of those columns. So it depends, like most of the cases like database perspective, right? So they are going to create all this and they are going to try to avoid those role play dimension, but you can also duplicate and you can rename those whatever the dimension, right? You have a date, right? You can make use of as alias name and you can make use of as end date. But in general, if you want to make use of existing columns, right, you can replicate, you can duplicate. It is more flexible in reporting tools and it is more flexible in in-memory tools by making use of duplication of columns, and you can use in different, like in different perspective as well. I'm going to showcase in like hierarchies, the same kind of a scenario. We have a hierarchy where some of the users want to drill down from year to quarter, and sometimes the user wants to drill down from year to season wise sales. So same drilling option, but the similar way you have to avoid this one. So it showcases the naming convention, right? This is a start date and this is an end date. So we can understand, or something like date of joining, date of relieving, or start date, end date, or we do have ship date, order date. So these are all dates, but we have to create an individual dates based on the data or based on the naming convention or based on the business. In general, we do have today, but this is today, and you have a function here. Let's go with You can also go with today here, today function. You got it right. So today's date, and we do have now. You can also go with now. So it shows today's date and time. Okay, it is taking some time. But we have today function. You can capture today's date, and we do have now function as well. So I can make use of now. Now I can see 2/19/2017. You got it right. And you can also type in here now. It shows date and time. So these are the functions. So you can make use of today, and you can extract year, month, quarter, and whatever the dates, right, by making use of this date. But I want to make use of specific date. That is what my point. I want to make use of specific date or individual dates. So this is what date and time. You got the point, right? So by making use of now function, you can also go with calculation fields, today or now, today, and you can go with the now function. You can create those calculations. No issues with that. So remember, we have to avoid role play dimension by making use of aliases, or when it comes to like database perspective, right, they are going to create all these things. So no issues with that. But role play dimension is nothing but if a dimension is going to play multiple roles, it's called role play dimension. The same thing, date is acting as an order date or ship date or start date or end date or required date. We do called as canonical dates. Most of the case, right, so we do struggle with the calculation part by making use of date related information. But in Tableau, we have a flexible function with date related, or like whatever the date functions we have, right? So these are more flexible. So every time no need to go with a database perspective. We can create all those functions or all those related information in Tableau. We have that much flexibility. And it's clear, right? So role play dimension. If a dimension plays multiple roles, we need to avoid that particular role play dimension because of the user's perspective. So they may get confused between these information like date or whatever the columns we have, right? So we can make use of alias name, or you can rename, and we can showcase that as a perfect example like start date or end date. So what is meant by degenerate dimension? Degenerate dimension, we are aware of fact table, right? Fact table. So we know like we have fact table. So fact table consists of facts and key columns. So this is a fact table. So fact table consists of facts and key columns. But we have one more column called degenerate dimension. So we have one more column called degenerate dimension in a fact table. So we may have or we have. So because what is the definition of degenerate dimension? If a dimension which resides within a fact table, if a dimension which resides and does not have any dimension tables, and does not have any dimension tables. So what is the meaning of does not have any dimension table? So we have day ID, right? So we do have day table. We do have date table. So or time dimension table. So we have day table, and day ID is related to that particular fact table, or sorry, that particular dimension table. But when it comes to like degenerate dimension, these dimensions which resides within a fact table and does not contains any relationship. That means it does not have any parent table. You got the point, right? So example for degenerate dimension, we have bill number, bill numbers or invoices. We may have, or we have these kind of columns within a fact table. So it's a simple definition. Degenerate dimension is nothing but if a particular dimension which resides within a fact table and does not contains any dimension table or does not host like any particular parent table. Got it, right? So now you got the point, right? So in a fact table, we may have facts, we have key columns, and we do have degenerate dimension as well. But we may have dimension, we may have degenerate dimension, or we do have. So example for degenerate dimension is bill number or invoice number, because you don't want to go with bill description. So in general, you can go with the hotels or bills, right? You'll get a bill number. It's a simple bill number or invoice number. You'll get all the information there. But it's something like a number or a serial number or whatever the number, right? So you just want to showcase the information regarding that particular business, bill number or invoices. So that is called a degenerate dimension. Degenerate dimension, which resides within a fact table. And we do have junk dimension table. What is meant by junk? Junk dimension. Generally, like cross join, right? Cross join. So it's the similar kind of a thing. We do get the same kind of a data while working with junk dimension. So junk dimension is nothing but if a dimension table is going to add with any particular like flag related values, or let's go with a simple one. So if a table is going to add with any flag related flag values, something like yes or no, or true or false, it's something like a Boolean statement, right? So we have Boolean, and we do have like married, unmarried, or married single. So if a dimension table is going to add with flag related values, we do get all the combinational data. That is what junk dimension. Let's take a simple example. Let's take serial number and we can go with the gender. So it's not a key column. Serial number is not a primary key or foreign key. It's simple serial number. And let's go with one more table called S number and marital status. So 1, 2, go with the simple serial number 1 and 2. Married, single. So this one table and this one more table. So if you want to concatenate is nothing but adding of those two tables, right? So concatenation of adding. So don't go with the straight away place, because in Excel it takes that cell. So whatever the cell we are going to click, right? So it takes that cell. So straight away you can make use of some string coding here, like double quotes. So I want to add this table to the flag related table. So something like married or single. So we have serial number and we do have serial number. So the result is S number, gender, marriage underscore status, marital status. So 1, male, married. 2, male, single. 3, female, married. 1, So this is what it is, almost similar to cross join, right? You're aware of cross join. So all the combinations, got it, right? So we have two records here and we do have two records. So cross join is nothing but, so you can add, like, sorry, you can multiplicate. So 2 into 2, we do get 4 records here. So this is called as a junk dimension table most of the cases, right? So if you are dealing with flag related values, we do get a junk dimension table. So it's a simple definition. Types of dimension, we do have all these types of dimensions. conformer strength role play, degenerate, and jink dimension table. But importantly, we do have slowly changing dimension because it's related to the data warehouse. So the actual database, whatever the data warehouse storing of information, right? So now we can go with the slowly changing dimension. So what is meant by slowly changing dimension? What is meant by slowly changing dimension? So slowly changing dimension is nothing but if a dimension, it is important, like when definition perspective or in interviews, it is very important. If a dimension keeps on changes, if a dimension keeps on changing across the time period, keeps on changing across the time period is called slowly changing dimension. If a dimension keeps on changing across the time period is important, is called slowly changing dimension. And we do have majorly three types of SEDs. So SED type 1, SED type 2, or yeah, type 2, and SED type 3. So we have type 1, type 2, and type 3. So what is meant by SED type 1, type 2, and type 3? We'll see that. But what is meant by slowly changing dimension? If a dimension keeps on changing across a time period, let's take a simple example and we can relate with all these types. So we have serial number, the same thing, S number, or let's go with SIM, like S number and employee name, EMP name. And we do have organization or company details, company and experience in years. Let's take a simple example. So we have serial number, employee name, company, and experience in years. So let's go with one person, one or single record, John. And current organization is, let's take TCS. So not current, let's take like first he joined in TCS in 2010 or 2011. So from 2011 to 2013, he works in TCS. You got it right? So that means let's put aside here the number of years and how much experience he do have here. 11, 12, 13. So he have three years of experience. You got it right? So 3 years of experience here. So that means the person joins in an organization in TCS. So he worked for 3 years. So his experience is 3 years till 2013. And he got another opportunity. The same person got another opportunity in Infosys or in Infi. And he worked from, let's take complete year. So from, let's take complete year. We don't want to go with a specific month and all those things. Let's take 2014. And from 2014 to 2016, he worked for Infosys. Let's go with 3 years, 14, 15, 16. So now we can see with the data. So let's put aside years is okay. It's a count. It's count like based on number of years. But if you can see right, serial number, it's a simple number to fetch a particular record. It shows the record count, employee name. But if you can see company, now the company changes. If you got another opportunity, you got it? If you got another opportunity, he joins in one more organization. Let's take IBM, right? And with current like experience, some 0.2 years of experience. So now till date or current year, or you can go with 2017. You got the point, right? So whatever the dimension, right, keeps on changing. If a dimension keeps on changes across the time period is called slowly changing dimension. It changes, but it depends on the time period. That is what the point. It changes. So you can also take one more example with the location. He may work in different location, California. He may work in different location, New York, or different location here. You got it, right? We can also take location as one more example for slowly changing dimension. Got the point? Slowly changing dimension. If a particular dimension keeps on changing, so that is what SED type. And we have three types of SEDs, right? Majorly we have three types of SEDs. So what is meant by SED type 1? It's a simple definition. So we do have like, this is a simple example, serial number, employee name. We may have employee ID. So we can make use of employee ID. So it's not with a relationship. We can make use of relationship, no issues with that. But like whatever the tables, right? So we can relate with a fact table or whatever the salary table, right? In that salary table, we can make use of employee ID there, and we can establish those relationships. But this is a kind of a table where we can make use of the information related to company. You can make use of any key column. Yes, it is related, so no issues with that. You can establish relationship. But the only important thing is like the dimension, which keeps on changing. And this is what? So by making use of surrogate keys, so we do call that surrogate keys, the combination of something like composite keys, combination of two or key columns. So we have a concept like in backend, they are going to make use of some combination of key columns. So by making use of employee ID and this complete, like you can see the record, right, for regarding this company, TCS is one, and you can make use of Infosys with this particular employee. So they can relate, so no issues with that. So by making use of some key columns, combination of key columns, they can establish relationship between those company related and salary related information. So, but importantly, we have a SED type slowly changing. So we have the dimension which keeps on changing across the time period is called SED. So type 1. So what is meant by SED type 1? So slowly changing dimension type 1. So type 1 stores only the current information. You got it, right? So it's a kind of a database. It's a functionality where it stores only the current information. If the requirement comes to store only the current data every time, right, we can go with the SED type 1. But it is not preferable for the reporting tools. So as a reporting person, I have to go with purely like I have to go with the historical data for the better business analysis. You got it? For the better business analysis, I can go with whatever the historical data we do have. But slowly changing dimension type 1, yes, it will overwrite all the time. Yeah, it's a good point. It will overwrite. So now the current companies like IBM, so within a couple of months, I got an opportunity. Let's take John got an opportunity. So in Capgemini, CG, so you can take any organization. And so just join and it will overwrite. It stores only Capgemini related information. Every time it stores current information. It overwrites whatever the newly loaded record, right? It overwrites that particular record, but it stores only the current information. Yeah. So that is what slowly changing dimension type 1. It's a simple definition. So when it comes to like this kind of a table, it stores only the current information. So whatever the newly loaded record, we will get only that particular record. So for the analysis purpose, so you can take the experience. So let's take this record. He has only 2 months of experience. January and this current month, February. But when it compares like, so I just want to go with experience wise. So I'm checking with the experience, like if we have 1 year of experience or more than 3 years of experience, we need to give some, look how long in the sense, like in general, it's a dynamic, like it's a real-time data. So every time it checks with the current record. Or you can go with the max of, right? What is meant by max of date? It shows the last record, right? Or current date or last date, whatever the data we have. Something like it's a functionality where it stores only the maximum record. If you're working for 10 companies, whatever the last company or whatever the current company we are working, it stores that particular record only. It is not going to store all these records. We don't have all the historical information. So we are not into like SED type 1. That is the point. We are not into SED type 1. So if you want to showcase only the current status of particular information, I just want to use the current status, something like status, you can go with SED type 1, whatever the status we have for now. But we are not into SED type 1 because SED type 2 stores all the historical data. So generally like delete or truncate or whatever the operations, right? It depends on the functionality of the database. So we are not going to take care of those things because whatever the database, now you can see it stores all the historical data. So we already discussed with historical data. So whatever the data, right, from source systems to data warehouse, we do get this particular kind of a data. So we do have historical 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 data. And you got it right. So they are going to extract, they're going to run those extracts or transformations load into, right? So whatever the information we have gone through that. So they are going to run these job files. Whenever the newly loaded record comes, right, it overwrites, simple. Or you can store only the max of record, only one single record. You can go with only max, it stores only one single data. Or you can make use of overrides and you can make use of only one single record. So no issues with that. So it based on like the backend database process they do follow. And most of the cases as a like a reporting person, so we do go with only historical data. So that is like SED type 2. This is important point. It's a simple definition. You just go with the definition. What is meant by slowly changing dimension? And SED type 1, type 2, and type 3. So type 1 stores only the current information, and we are into type 2. Like SED type 2 stores all the historical data. SED type 2 stores all the historical data. That means you can see right all the historical data. This is an example for SED type 2. It stores individual records like 2, 3, 4. If you have fifth record, it inserts fifth record, and we will get all the information here. Got it right? So this is what type 2. And what is meant by type 3? SED type 3, slowly changing dimension type 3. So type 3 stores current information and previous information. Type 3 stores current and previous related information. So generally like we do have current. So you can see right. So when it comes to like this particular point of view, so we do have three companies here. So it stores only the current data and previous data. That means it is going to store so second and third, but it's not the table structure is totally different. So it is going to use, or we are going to get one more extra column, employee name and current company. Based on a date, they're going to create based on a date and previous company. We're going to get an extra column here, not with an extra row. That is what the point. So the only SED type to stores in row level data, we do have multiple records, or it's a real-time data. But SED type 3 stores current information and previous information. So serial number, so S number, or you can go with we don't have multiple records, right? Just go with the one. John. So current company is like now IBM and previous company is Infi. Got it right? And we do get the related information based on company wise experience. So this is what the structure I just want to showcase on a high level. Okay, this is what the structure, employee name, current company information and previous company information, but we do get a new column added here, not with a new record. And if it changes any company, right, it overwrites. So now IBM comes into here and one more company or Capgemini or whatever the company, right, Deloitte, or you can, it comes here. Got it? So this is what slowly changing dimension, type 1, type 2, and type 3. So type 1 stores all the sorry, type 1 stores only the current information, type 2 stores all the historical data, and type 3 stores current information and previous information. This is what the data warehouse, the importance of data warehouse where no, type 3 is not going to store all the 3 years, right? So all the years, whatever the data. So you can see, right, only IBM and Infosys, we do have only relation data across last 2 years, IBM and Infosys. I don't have TCS related record. It is not going to store all the historical data. Type 3 stores only the current record and previous record, not previous information in the sense previous record. Let's go with the record. Current and previous record. We are not going to take care of it. Depends on the columns. Now it is company and it depends on location. It depends on the specific column. Yes, all the years of IBM and all the years of Infosys. Yes, correct. It depends on a particular column. You may have location as a slowly changing dimension. So in that case, you have to go with that particular dimension. Yes, yeah. So this is what the data warehouse. And importantly, we have star schema and snowflake schema. That is very important because we need to involve in the data modeling. Got it, right? Whatever the modeling we are going to do, right? So we need to identify it. Simple, not that complicated. So I can provide, like I do have some materials regarding data warehouse. You can also search in Google, no issues. Like you'll find some of the PPTs and all those things. You can go for it. Yeah, we do have. And 1 minute, 1 second. So we'll start with Tableau. So we do have Tableau desktop. These are Tableau components. We do have components of Tableau, Tableau desktop, Tableau server, Tableau online, Tableau public, Tableau reader. Yeah, you can go with, you can take 5 minutes break, so no problem. Sorry, yeah, you can take 5 minutes. Yeah, no issues. Yeah, thanks. Sorry, like we can load, sorry, like whatever the data we have, right? So whatever the data, it's a tool, first thing. So first point is, so by loading the data into Tableau, whatever the data, right? So we're loading the data into Tableau. So it depends on the database first. We can load the data into Tableau and we can do some data modeling. But if you want to embed, so I'm not sure with Tableau reports into other thing, but if you want to embed this particular links or something like I want to like log into to only one single web page every time. I don't want to use Tableau server or Tableau online. So you can take this particular reporting links and you can embed this particular reporting links into that particular web page. So that it's a single sign-on where you can log into that particular web page and straight away you can access these reports or dashboards. So that is possible. But whatever the reporting, right? So you can connect. So let's go with Tableau desktop. So first thing, Tableau desktop, first point, like it's a development perspective. We can use Tableau desktop for development. Tableau desktop, and we do have like Tableau server and online. So what is the use of Tableau server and what is the use of Tableau online? So for publishing the reports. So for publishing the reports into server or online, we can make use of Tableau online or Tableau server. I can showcase that, but importantly, we have Tableau server and Tableau online. So it's a cloud. Tableau online is a cloud. We can use straight away. We can create Tableau online account and we can publish into online. And we can log in into Tableau online or users are going to use this particular account. It's for publishing so that users can able to view these dashboards because it is not possible to install Tableau desktop for all the users and we cannot share these workbooks, right? It's so security. So that is the point. We are going to develop, we are publishing into Tableau server or online so that users are going to access these reports or dashboards. Tableau public is free. Tableau public is free. Free in the sense it's straight away you can download. No no restriction for license. And it is almost similar to Tableau desktop, but we cannot connect to DBs. We cannot connect DB. So we cannot, it is not possible to connect to the database by making use of Tableau public. So these are very important, these three components, Tableau desktop server and online. And this is also pretty much flexible, Tableau reader. So we can access offline. So we can access Tableau workbooks in offline access of workbooks. So initial stage of project, right? So if they are going to share these workbooks, so we can make use of this particular workbooks, like whatever the Tableau workbooks we do have, and you can do some analysis as well. Got it? So first point, Tableau desktop, and the current version is 10.1, and we are like waiting for 10.2. So we do get 10.2 version as well. So within a few days, and now you can see we do have 9th version. So try to install 9.0 or 9.1 or 2 or 3. You do have subversions as well. You can install all these versions. So that is what like the advantage with Tableau. You got it right. I have 9.3 version. I have 10.1 and I do have 9.2 as well. 9.2, 9.3 and 10.1 version. I don't have 10.0 but you can install. So it depends. You can go with a 10.0 or 10.1 and 10.1.1. We have subversions as well. So first point, advantage with Tableau is you can create multiple versions. Sorry, you can install multiple versions. And the only thing is it is for 14 days. Only thing is it is for only 14 days. Desktop or server or online, it is only for 14 days. In general, for if you want to work with all these components, right? In real time, they do have real time license, so no issues with that. But for 14 days, we are going to work with only 14 days. But if you want to get the student license, we have an option called student license. Tableau student version. You have a Tableau student version, right? Just click on Tableau student version, Tableau for students. Get Tableau for free. So you're getting these fields, right? You have to fill all these fields, confirm the email, and you can go with date of birth. After submission of this, you'll get a prompt. So I'm going to showcase that. I'm going to give a simple names here. So let's go with so this is my mail and business postal code. Let's go with any particular code. Like you can go with the state, some submit. Now you can see, right? You'll get a prompt here. You're almost there. Please upload a supporting document showing your current status as a student. So if you have a relatives or if you have a like friends who are pursuing any education, try to upload those like ID cards, current student ID card or current course schedule or an official verification document on school letterhead. Documents must include your name and date of validity. So no issues like validity in the sense current status must be as a student. This is important. You can go with any particular document. So you can choose a file and you can upload the document and click on upload documentation. Simple. So no issues with that, right? Like you can upload whatever the original or whatever the things, right? You can upload, no problem with that. Or you can, if you have an ID card, like student ID, you can upload that as well. So you'll get a mail to the whatever the mail you're for 1 year, and we can go for 1 year validation, like for this particular license. Any issues with that? Like any questions regarding license? It's simple. And first point, you can install any particular system. It supports Windows and Mac. GB RAM, no issues. And straight away you can download and you can install Tableau Desktop. It doesn't ask like Adobe Reader or any particular files, so flash mode or something. So straight away you can install Tableau Desktop and you can work on. Got it, right? So this is the importance of Tableau Desktop. It is more flexible actually. When we compare with other tools, right? It is more flexible. Tableau Desktop. And Tableau Server and Online, we can install Tableau Server. We can host the server. And flexibly, we do have Tableau Online. Whatever the publishing, right? We can also go with Tableau Online as well. So this is the importance of Tableau Online. So let's go with version. You got the right, you got the point, right? So you can install any version, any particular version, but I'm going to teach in 9.3. So at least like you can install 9.3, go with point to 8.3. So if you want to compare, right? So generally they do have of 4+ years of experience into Tableau. So let's go for comparisons. So what is the difference between 8th version and 9th version or 9th version to 10th version? At least you can list out some of the points, right? At least 2 or 3 points. So they will okay, like they will okay with your answer. So that is what you can go with practical. So no need to search in Google what is the difference between 8th and 9th. Straight away you can install all these versions and you can compare those results. So this is the 9th version, 9.3 version. So this is a Tableau desktop. So from Tableau you can connect with any particular databases, more servers you can see, right? So you can connect with 40+ databases by making use of ODBC connection, or you can straight away click on Oracle, give the server name, and if you have user ID password, or you can also use Windows authentication. It depends on the database connectivity. And we do have 10th version, and I'm going to showcase that. In general, why we go for 9.3 in the sense, I'm going to explain in 9.3, and whatever the new features added in 10.1 or 10th version, right, I'm going to showcase that. That is what the flexibility. I'm going to differentiate with all the versions, most of the points. I'm going to cover with most of the high level points. So this is what Tableau desktop, and we can also, one more important point, we can also develop those reports in Tableau Online or Tableau Server. Not only with desktop, we can also log into Tableau Online or Tableau Server, and we can also create those reports or dashboards in Tableau Online or Tableau Server. You got it, right? So this is for the flexibility. So I have seen, I'm not sure, like we are aware of like some of the clients. I have seen in Caterpillar account. So we do have like more than 60,000 plus users are using Tableau. 60 plus thousand. It's like 60,000 plus users are using Tableau. So they do have their own sites. So whatever the developers are publishing their reports, right? They do have their own sites, and they can log in and they can also build those own reports. It's a general reports. So this is that much flexibility. So got it right? Tableau desktop or Tableau server online. You can create your own account, Tableau public, and you can do some visualization, and you can create those visualization, and you can publish into Tableau public. It's free. But this is what the thing. So for security and all those things, you can go for Tableau server and online. You can create your own sites, and you can publish. You can create users, and you can do all those things. So out of the admin related concepts, right? You can find here Tableau online or Tableau server. And this is what Tableau desktop. By default, whenever we are going to connect or whenever we are going to install Tableau desktop, right? You do get a default folder called My Tableau repository. It's a default folder, My Tableau repository. Just double click on My Tableau repository. You'll find all these folders, bookmarks, connectors, data sources, and you can see shapes, workbooks. I do have lots of workbooks here. Let's go with workbook. Like, okay, we are opening a file, but let's go with here. It checks with Excel. We don't have all files here. Let's go with documents, My Tableau repository, workbooks. Now I can see I do have lots of workbooks here. Got it? So you can go with data like My Tableau repository, and you can go with data sources. So you can check if you install whatever the versions, right? You can see the versions, number of versions here. I have 9.2, 9.3, and 10.1. Let's check here 9.2, 9.3, and 10.1. You can install more like whatever the versions we have, right? You can install all the versions, no issues with that. It accepts. That is what the flexibility. So now you can go with Tableau desktop, go with the data source. By default, we will get these data sources. You can load, you can find sample superstore data, sample data here, sample Excel file. So this is the Tableau desktop, and so we do have extensions in Tableau. So important Tableau extensions. So we have .twb, or let's go with the Tableau workbook, Tableau package workbook, and we have .tds Tableau data source, .tde. These are important, like these extensions are important, the first four. And you can also create bookmarks, Tableau bookmark, .tps Tableau preferences file, and .tms Tableau map source. You got it right? So Tableau workbook, Tableau package workbook, and these two are important. And we do get this kind of a question: what is the difference between workbook and package workbook? And what is the difference between .tds and .tde? It's a connectivity related information. So .twb is nothing but Tableau workbook. It's an in-memory tool, right? So it's an in-memory tool where You can store in any particular location. So Tableau workbook and Tableau packaged workbook. This is packaged. This is Tableau packaged workbook. And we'll discuss first into Tableau workbook and Tableau packaged workbook. So now you can see whatever the application or whatever the Tableau workbook we have, this is 9th version. Let's go with 10.1. You can check with the view as well. So you can check, like, let's go with Excel sample superstore data. Now I can compare with Tableau 10.1 and 9.2. Sorry, 9.3. You got it right? So the view has been changed somewhat. You can see drag sheets here, sample superstore data. You got sample superstore data here. And I'm going to showcase some more points. Let's drag and drop orders table in 10.1. Let's close this one. You don't want to go with the first initially. I just want to showcase in 10th version because I'm going to do some modifications here. Creation of packaged workbook and unpackaged. So this is the higher version I have, 10.1. And if you can see, right, I just drag and drop orders table here. You're aware of these all things, dimensions and measures. I'm not going to start anything. I just want to differentiate Tableau workbook and Tableau package workbook. Let's create a simple sheet. Category, subcategory by sales. Go with one more sheet. And let's create a bar chart. So click on save. Let's go with the documents, my Tableau repository. Let's create a new folder here. My tab. So double click and save as, you can see, right, save as tableau.twb. You can go with .twb or you can also go with a .twbx. It's up to you. Like, you can, by default, in general, it's a best practice. You can go with the .twbx, but I'm going to save as .twb. This is my workbook, or TWB, or like Tableau. So my workbook name is Tableau. Just click OK, save. So this is my Tableau workbook. The name is Tableau. Let's close. Go with the folder, my documents, or Tableau repository. You can find my tab. Just double click. Now I can see this is the Tableau workbook, and you can also see the type right here, Tableau workbook. So the importance is, so what is the difference between default database? So I'm not sure, I didn't see all the messages, what database need to use. So we do have like, we do have tab, like we can connect with any particular database. So it's not a default for Tableau. So we can connect for MSBI, we do have SSIS. So SSIS, SSRS, right? So for MSBI, we do have SQL Server. It depends on their objects. It depends on their databases. For mainframes, they do go with IBM DB2 or IBM like Netezza. For HP related products, they do go with HP Vertica. But Tableau is independent. So you can connect with any particular database. That is what my point. I'm sorry, I missed out some of the questions here. And have seen some of the questions here. Can we publish dashboard in Tableau server and it can be accessed from Tableau online? So yeah, online is a site and Tableau server is different. So if we have a same kind of a site, we are using that particular server, we can access. But most of the case, right, the online is going to create it from different site. So different environment or different cloud. We are going to use somewhere like a different site, and Tableau server is, we can host a server and we can create those Tableau servers or Tableau different sites. Got the point, right? So I'm going to create, I do have a Tableau online account. So I can create, it depends on the users. We have to publish whatever the server, right? We have to publish into Tableau online or Tableau server. We can use those options. No issues with that. It's not complicated. Now you can see we have a Tableau workbook. This is Tableau workbook. Just double click. I just want to we can access, right? You can store in any particular location, not only with the My Tableau repository. You can store in your own desktop folder. You got it, right? This is sheet 1 and you have sheet 2. You can store in any location here. You can go with the desktop level. I do have Tableau workbooks. I have sample, requirement, December.twb. I do have some workbooks here. Got it, right? So let's go with the folder. So we have an advantage. This is Tableau workbook. You can see the size of the workbook is 66 KB. Now I can also convert Tableau workbook to Tableau package workbook. Just right click and you can create a package. I'm going to showcase that. What is the advantage of package? I'm going to showcase that. So just right click, create a package. Now you can see, right? We have Tableau workbook. The size is 66 KB and Tableau package workbook and the size is 1.16 MB. Remember, you can save as Tableau workbook or Tableau package workbook. Now I'm going to delete Tableau workbook from my system. It's a permanent delete. Shift delete. Are you sure you want to permanently delete this file? Tableau workbook. I'm going to delete this workbook. I do have only Tableau packaged workbook. Just open this Tableau packaged workbook. I just want to differentiate these two, Tableau workbook and Tableau packaged workbook, and what is the importance of that. When we compare with traditional BI to in-memory, this was the flexibility. This is a Tableau package workbook, but we can see the same results, right? Sheet 1 and sheet 2. Let's close. Any doubts here till now? Tableau package workbook and Tableau workbook, we can access, we can just double click and we can showcase those results. But what is the actual difference between Tableau workbook and Tableau package workbook? Now you can select, right click, package of Tableau workbook, but you can also create and package. You can create and package folder here, Tableau dot or whatever the naming convention Tableau, Tableau.twb files. The application size is 1.19 MB, but we have a package. It's something like a zip file. So we just extracted this particular zip file, and you will get this particular folder like .tw. Double click. You can see data. Click Tableau package workbook. You can share files. And what is the advantage of Tableau package workbook? It stores all the external files. This is important. It stores all the external files. So what is meant by external files? Let's go with Tableau package workbook. Go back here. So we have Tableau. It's a workbook. You can also double click and you can showcase the same workbook. But just double click on here. You do find sample superstore data with 3 point something MB. So that is 3.22 MB. but my actual workbook file is 1.16 MB. So that means it compress. That is what the in-memory. It compressed data. So most of the case, right, it compress almost like 1/3 of the data. It compress almost 1/3 of the data. So I do have some more files. I can showcase that. But if you can see, right, so we have used this data model. So let's take the properties. Let's check the properties. And the size of the workbook is 23.7 MB. You got the right, you got point, right? So 23.7 MB, the size of the workbook. But in general, the size of the workbook, like I have loaded Tableau tutorial data, right? It's MS Access database. The size of the workbook, like you can see, not sure here. Let's go with the size straight away. It's in downloads. Yeah. Huh. It converts into Tableau file. Generally, you can see, right? It is showing as a Tableau icon here. It's a Tableau Microsoft Access database. So you can see the Access database file size is 100 MB. You got it, right? So, but the size of the workbook, whatever the size of the workbook we are seeing, the size of the workbook is 20 something, like 24 or 25. So it compresses that particular part of data. So almost like 1/4 of the file it compresses. So that is what in memory. You can extract, right click, you can unpackage. So that we'll get a dot, whatever the .tw files, right? You'll able to see like MS Access database. So let's go with this folder. I'm going to showcase one more point here. We have my tab, right? So let's delete these external files or whatever the things, right? Or let's go with permanent delete, shift delete. Now try to open Tableau package workbook. It's clear, right? So this is important. The terminology and the basics is important when we work with Tableau. So this is simple sheet 1 and sheet 2. Let's go with one more dashboard. I want to load images. I want to load images. I'm going to explain all these things, but just I want to load an image. Let's go with the image here. This is what the image. I want to load an image and I want to save this workbook. Click on save. Click close. You know, like the image, the path of the image is like in pictures. Got it, right? In pictures, we do have all those images. So now I'm going to click on extract, right click or click on unpackage. Now you can see we have a Tableau workbook. Initially it is like 66 KB. Now it is 162 KB. We have Tableau package workbook. Initially it is like 1.8 or something MB, right? So now you can see 2 point some. But just double click on .twb files. Now you can see we do have only data, but you can see image folder as well. It creates an image folder. Now you can see the image, whatever the image we have loaded into .twb or whatever the workbook in, right? You can see that image here. So that means it embeds. It's something like a zip file. It embeds that particular external files. So you can share this particular workbook to any particular person or any particular location or environment. You can go with a production or you can go with a QA or UAT or SIT, whatever the environment, right? So if you have different environments, if you are going to publish into different environments, if you are using some external files, we have to place all those images into that particular server so that it loads something like absolute path or relative path, right? It takes that particular path and we do get those results. That is the case in traditional BI. But when it comes to like in-memory tools, no need to place all the external files in different servers to get those images or whatever the external, right? So it's flexibility. Create a Tableau package workbook and you can straight away, you can publish into server. You got it? So that is what the flexibility. It embeds all the external files within a Tableau package workbook. I can see the size of the application, 4.03 MB. Size of the workbook, Tableau package workbook, it's a 2 MB. Got it? You got the difference, right? So this is important. It's simple. Generally, we do go with Tableau workbook or Tableau package workbook. Anyway, like whatever the data or whatever the application we are logging to write into remote desktop or VPN connectivity, there we can straight away connect to Tableau, like Tableau desktop. You can save as Tableau workbook or Tableau package workbook, but the best practice is you can store as Tableau package workbook because it stores all the external files, and you can also share these workbooks to your friends or any particular person. You can email these workbooks, and if you have a desktop, right, he can straight away log into this particular workbook. At least he can browse, at least he can edit those workbooks. But if it is a live connection or if it is a database connectivity, we have to send the connectivity string. If it is a licensed, so it is not possible to connect, but we can edit. We can edit this package workbook. We can do the development part as well. That is what the advantage with Tableau package workbook. Any questions here? Difference between package workbook and Tableau package workbook? In general, it stores all the external files, package workbook, and it's a best practice to save as .twbx. It's simple. Yeah. And we do have .tds and .tde. So I will take more like 10 minutes or 15 minutes. I will stop the session. So no issues. Clear, right? Or you're okay with that?
Yeah, we are okay.
Sure. Yeah. Thanks. Okay. So TDS and TDE, this is important. So TDS is nothing but Tableau data source. Tableau data source, or it is also called as live connection. Now it comes under the connectivity information. .tds is nothing but Tableau data source. And .tde is nothing but Tableau data extract. That means TDE file, Tableau data extract. So what is meant by .td? So live connection, we are already aware, like I'm going to showcase that. So extract in the sense, so whenever we are working with Tableau data extract, right? So it's something like cube. You know, like you are aware of cube concept, static databases. This is static database. So for a better performance, we have live connection and extract connection. If you are working with live connection, in general, let's go with the Tableau. We do have two connectivities. So you can differentiate with Tableau public as well. In Tableau public, we don't have a live and extract. Straight away, we are using flat files, right? So you do get, just click on data source. Now I can see you have a connectivity information here. If you want to go with a live connection, just click on live. Every time it shows live and connect directly to your data, the speed of your data source will determine the performance. So sometimes the database may degrade the performance. So if you can compare, that is what the option, the speed of the data source will determine the performance. If you have Oracle, and if you are going to run a report on the top of Oracle database, let's take it takes 3 seconds. Right? I do have same data in SQL Server. So how much time to get the same report? I'm going to run in Oracle. It takes 3 seconds. With the same compatibility settings and all the RAM size or whatever the configuration, right? With same configuration, it may take 3 seconds, or it may take 4 seconds, or it may take 2 seconds. Not with much different, with a slight difference. So in the similar way, you can compare with all the databases. It depends on the functionality of those databases. Some database may degrade the performance, some database may increase the performance. It depends on the connectivity. But while working with a live connection, it's every time live connection. Every time it's a live data. So that means in general, we can also get the live information from extract. But live connection is nothing but every time it hits the database and we do get the data. That is what mean by live connection. Got it right? And Tableau generates .tds file. While working with live connection, Tableau generates .tds file internally. It's not like manual process where we can save, but we can store .td file. I'm going to showcase that, but .tds, let's search here, .tds. You got it right? We have sample superstore connectivities. These are connectivities. You can also click on this. You can also open the .tds file as well. It's a simple connectivity string. So it opens in it's similar to Tableau workbook. It stores the data here. Connection live, and we can see the data here. Same workbook, right? So .tds is nothing but it's a connectivity string. So this is important, connectivity string. And if you want to share this particular connectivity string, you can share those .tds file as well. Something like a connectivity string. But whenever you're working with a live connection, it takes .tds. And in general, it's a live connection. Every time it hits a database, every time it is going to hit the database to get the data. So on a high level, I'm going to explain you in detail. But what is meant by extract? What is meant by extract? It is called as static database, or we can also compare with cubes, cube concept in traditional BI. So why we go for cubes? You know, like you are aware of cubes. Cube is nothing but static database. We do call as multi-dimensional cube. And we can store subset of data into cube like cube or .td. So in Tableau, we do call as .td. So for a better performance, if live connection, this is very important. If live connection, not for 3 dimensions, like it's a multi-dimensional, like MVOLAP. So in general, we can differentiate with RVOLAP. It's a RDBMS. It's a static database. It is called as MVOLAP, multi-dimensional, what is called as cube. So if live connection degrades the performance, we can go with extract. We can use extract. It gives a better performance. So I do have extracts. So we can make use of extract, subset of data, but it is static. But if you want to refresh, so from Tableau server point of view or online point of view, you have to schedule those extracts. You got it right? So it's an extracted database. So something like, I'm going to showcase the extracted database. Now just click on extract. Extract will include all data. If you want to filter out unwanted data, you can also edit. You can apply some filter. Just click on sheet 1. It's creating an extract, right? Now you can see it's creating an extract. So whenever you are going to save a file, initially I saved file as Tableau, right? So if you're not going to save a file, let's save, okay, no issues. Let's save the file and close. Now let's create one more workbook here. I'm not going to store, like save the file initially. Let's create an extract so that you will be able to find extract. So click on Excel, sample superstore data. Order sample superstore. Now you can see extract. Let's create on extract. Just click on extract and go to sheet 1. Just click on sheet 1. Now you can see it prompts to tableau.tde file. It prompts to .td file. Now I do have lots of extracts here. I do have lots of extracts. Now you can go with order sample superstore extracts.td file. You can go with a different naming convention. With February, or if you want to go with the February date related information, exact date, February 19th. Click on save. Now you can see, right, the difference between extract and live. So this is extract, and you can see extracted data includes 2/9/2017 till 10:14 a.m. 10 whatever the hours, right? You can see 10 hours 14 seconds. So till date and time we do get the data. So other than that, so we are not going to get a real-time data. But if you want to refresh, you can refresh. But in general, it's not a manual process, right? So from Tableau server point of view or online, we have an option called subscriptions or schedulings. We can schedule those refresh across day level or every hour level, or you can also go with the lowest level is like 15 minutes. Every 15 minutes, right, you can refresh that particular extract. So this is extract, it's a subset of data. And now I'm going to save this particular workbook. Customer related information, customer by sales, and let's go with image. Click on image, try to load image. So this is in users public pictures, right? This is in different folder. I do have image sheet. Now click on save this workbook. So I do have, this is T1. Let's go with T1 and save as .twbx. Click on save. I just want to differentiate with .td file. That is what my point. Close, go with the folder. Now delete all this like unwanted like workbook and .twb files. So I have Tableau package workbook, first one, and second I do have T1. Now right click on T1 and package. I have image, and let's check with the other file. So that is what the thing. You got T1 is a Tableau workbook, and you have .twb files. Just double click. We have image. Okay, we do got image, this one. Let's go back. We have data sources. Now you can see we don't have any Excel file here. You got the point, right? So that is the importance of .td and .tds. You don't have an external file, so you don't have an Excel file, actual data file what we loaded, right? So it is using .td file. I created orders TD February 19th data, right? It is using February 19th, whatever the .td file. But you can also convert straight away. You can also convert live connection, and you can also convert from live to extract. Because default, this is a local system, and if you want to switch over to the live connection, just right click or just go here, data source level. You can switch over to live. This is a live connection. Just go to sheet 1. You can see the symbol, right? You can see the symbol is live. Data source symbol. It's a data source symbol, right? It's a live because you are in live connection. But you can also convert to extract. Just right click, use extract, or just check here, it is extract. You can also convert from here, or you can also convert on the top of data source, right click and use extract. So this is what like live and extract. You can convert to live, and you can also convert to extract. But you may get a doubt. So I do have only .td file. How it is possible to connect to a live connection? Because default, I said, right, so default it creates a connectivity string .tds file. It uses that particular .tds file connectivity string and it connects to the live connection or connects to the database. But if you have an extract, it embeds whatever the external files. Extract is a subset of data. It embeds within a Tableau package workbook. Now you got the differentiation with Tableau package workbook and workbook, right? So you got .tde files as well. It stores .tde files. It stores images. It stores flat files. You got the point? Yeah, in extract, we didn't get an updated data, but you have to go with a refresh. Extract, you can go with a refresh. This is from desktop point of view. It is in desktop point of view. We can refresh manually. We can right click and we can just click on refresh. But in server point of view, because like we have to go with automation, not with a manual process. In server, we can create a schedules. We can create a schedules. I'm going to showcase that. We can create a schedule every day wise or every hourly or minutes. Like the limitation is minimum we can go for maximum we can go for 15 minutes. Every 15 minutes wise we can refresh this extract. Got it, right? So this is what the advantage of Tableau workbook and Tableau package workbook and live versus extract. I'm going to showcase in detail with extract. We do have some more options in extract. We'll discuss with the live and extract for the next class. Any questions? Is that clear? Workbook, Tableau package workbook is a functionality. So it's an in-memory tool so that we have a flexibility where we can store in Tableau package workbook, so whatever the all external files, right? So this is what the information. Clear or any questions here? Yeah. Yeah, thanks. Yeah. Yeah, thank you.
So, hi guys. So just now I shared a Tableau training session folder to you all. Please check your mails. And Ramesh, can you please send the notes or whatever the material you would like to share? Could you please share in that folder which I given access to you?
Sure, sure.
Yeah,
Sure, yeah, I will do that.
fine. Thank you. We'll meet you in tomorrow session. And so today's session is very good. Thank you very much. Bye. Take
Yeah,
care.
thanks. Thank you. Bye.